Thank you. Good evening, everybody, and thank you for joining us today for one of our online networks. My name is Saira Ahmed, and I'm Senior Qualifications Manager for GCSE Maths. I hope you're all doing well in these ever-changing times, and today's network will be on problem solving at GCSE and will be run by Pietro. Many of you have met the legend that Pietro is, who has run many of our face-to-face and our online networks to date. The focus of today's session will be problem solving at GCSE, with a key focus on looking at how one would define problem solving, simple ways to embed problem solving into your lessons, using problem solving techniques to organise a rock concept via an extended project opportunity. The main part of the session will be using bar models as a tool to solve problems involving ratio, percentage, fractions, and simultaneous equations. And finally, strategies for approaching show-that questions. Pietro's session will be then followed by Mark Howlett, who will be providing an update on any recent Ofcom announcements around examinations, and then we'll go straight into the last half an hour, which will be an open Q&A where delegates can ask Pietro any questions on teaching and learning around GCSE Maths. We will endeavour to answer as many questions as possible during the next 90 minutes. However, if we can't answer all your queries, we will make sure that we will follow up with you after the event. Please do use the chat Q&A box to type in your questions to ensure a Pearson representative will be able to answer your questions. Pietro has prepared an extensive array of resources, as many of you know, that we hope you'll find really useful in your teaching. These can be found via the link provided at the end of the session. So towards the end of Pietro's session, before the Q&A starts, there will be a downloadable link where you'll be able to download the presentation that Pietro is using today. You may well refer to some of these resources during the session, but please do wait until the end before accessing these. After the session has ended, an evaluation form will appear on your screen. If you have time, we would really appreciate your feedback on this event and any suggestions or thoughts on how we might improve it moving forward. Thank you so much. I hope you enjoyed today's session, and I will now hand over to Pietro.
And thank you very much, Saira. Hello to everybody here. I hope you can see me as well as hear me. So for the next hour, just about an hour, I'm going to be looking at problem solving. Just waiting for my slides to come up via the host, who makes things happen. So the slides are there. They are magic. They're there. I do hope everybody is well in your schools and your families, and in these uncertain times. So my thoughts are with you. Okay, so let's make a start at problem solving. This is a repeat of a session I did a few weeks ago. A lot of the resources I'll be referring to are going to be in the Google Drive, which you'll get the link at the end. You'll also get a download for this PowerPoint via this platform, and a kind of worksheet on bar models that I'm going to be referring to later on. So let's crack on and make a start. So this is a little bit about me and my experiences, the things that I've done over the last 35 years of teaching. So I won't go through them and bore you, but there they are. The other thing I'm saying, you can make some notes. You do need a pen and paper, because it might be the odd little question I might ask you to have a look at. Just makes it more proactive rather than just you listening to me. But there are slide notes when you download the PowerPoint with quite a lot of detail. So even though you're making notes, a lot of what I'm saying will be summarized in the slide notes. I've done that already. So this is kind of what I hope to go through in the next hour or so. I'm not going to read through the kind of session agenda here, but that's kind of keep me on track. But as Saira said, the bar models will dominate this because it's an excellent tool for solving a whole host of problems. So I'm going to start with our first chat. So in the chat window, the first thing I'd like you to do is, could you write a sentence kind of summarizing your definition of problem solving? So I'd like you to do that if you could. This is in your chat window, your group chat. There it is. This is my host has prepared it now for you to fill in. So I'm just looking at what you're writing. Obviously, we can see each other's responses, I think, in this format. loads of things coming through. Real life situations I see. Interpretation. Whoa, they're so fast because there's 277 of you. It's too quick for me to read. AO2, AO3 I saw flash up there. Application of more than one topic, good. Multi-step problems, real life application again. Lack of scaffolding perhaps. Okay, just to get an idea. And I think this is what students find difficult, because one size doesn't fit all. They want a formulaic approach, and it's not exclusively foundation students who find problem solving difficult. I think sometimes I've had students who've done higher tier that perhaps were really good at primary school. Maybe they were coached for their SATs. They're very good at the kind of arty subjects. But in mathematics, they got into a top set historically, but want a method to fit all, and that's where they get found out. So this is the definition of solving problems from the specification, which I've put up on the next slide, which a lot of you covered with your words. Yeah, but there they are. I think we'd all agree with them. This is a definition, kind of shortening it. I'm trying to get it into one sentence. So, a task where the solution is not immediately attainable and there's no obvious algorithm for the student to use. I've shortened it for my own definition, which there's a link, by the way, down the bottom there for some nice problems, or a bit quirky ones, like how to move a sofa out of a bedroom or out of a room. And you have to kind of bend it round because of the loci thing. But my definition of problem solving is the one at the bottom there. And it's almost like a kind of case study, like a role play. You have to imagine the student has got this question in front of them, and they look at it and they read it and they say, I know what I've got to do. In other words, which bank pays better interest? How many, I don't know, is there enough flour to make the cakes? Whatever it is. But then the student looks at it and says, but I don't know how to do it. And what they're saying is, I don't really know how to make a start. I'm not sure how to approach it. I don't know what to do and make a start to get going. And often, if they're nudged and they make that first step, then it's really good. So a couple of people can't see the presentation. Someone else saying they can hear the music. So hopefully my hosts in the background will try and sort that out. I'm definitely not playing music. Probably a refresh button's what you need to do.
Sorry, Pietro.
Sorry.
Can I just sort of interject and say, if anyone's having trouble, can you please just comment in the Q&A box for the host to be able to help you? Thank you.
No problem. Thanks a lot. Hopefully most people are with me. As I say, we got 289 now, so it's quite a high number. Anyway, so that's my definition. And I think this is what makes the problem difficult and demanding, I suppose we're allowed to say these days. We're not allowed to say difficult anymore. So what makes the task demanding? I'm not going to read through them, but these are the things that are the barrier to the learning and often will cause the problems and make a lot of the students just turn the page over. And not pick up any of those process marks. Often process marks are linked to these. And the predictability of the question, look at the bottom PowerPoint, at the bottom bullet point there. I think that's quite telling, because I can remember when the previous iteration of the specification came in, where we had problem solving and functional maths was coming in. I can remember some of the questions with doing ferry journeys and planning your holiday, what holiday we say at the moment. But they were quite demanding questions at the beginning because they were new, and all of a sudden they started appearing on quite a few of the practice papers and papers, and all of a sudden the students became quite good at them. So it's a problem if you haven't seen it before. If it becomes predictable, then it's not really a problem anymore. So it's kind of the first time they've seen it or some variation of it, then they got a better chance. Anyway. Its fluency, I think, is the start of it. If they're fluent and they've got all their skills that they need to use, these multi-stage questions with different skills coming into them, they have to use their brain power to solve the problem, not to remember the things they should know. So there's some examples there of arithmetic, simple things like knowing your tables. If you're going to do a ratio question, then you need to be very good at knowing your times tables, having the formulas at your fingertips, like, for example, there, the area of a circle. If you haven't got good fluency, then what you're doing is you're using your brain power to think of the things you should know, and then you suddenly are in real trouble when you're trying to solve the problem. So this is a starting point, and that's through your kind of regular starters and things like that. But it is important that they've got that fluency before they even think about solving the problem. And again, this is a little bit more detailed, I suppose, on the type of characteristics that some of these A, B, C, D, E, you will see in a problem-solving type question. Some of them, I think, you could almost say for every question. Some are on a few of them. Variety of techniques. This is a lot of what you were writing when we did that brainstorming at the beginning. But it's useful there just to have that. I think post-course this could be useful for some of you if you're a team leader or in a TLR, that you could present this to your new teachers just to make them aware if you're going to do your own internal training. So another quick discussion in your group chat window. So we now know what the difficulties of these problems are. So how do we encourage the students to actually have a go? So if you just like to fill in what strategies or things you would do to try and support your students to not turn the page over. Wow, they're coming in thick and fast, very hard to modelling. I like. Draw a diagram here. Open-ended answers. Goal-free problems I saw there, which is a very good website where they've got kind of just a question, and then you have to, well, not a question, a diagram or something, and you have to write a question around it, quite open-ended. Themed approach I saw. I see lots of breaking it down, scaffolding, and that's where the gold, silver and bronze exam papers and practice papers will help, which I'll be referring to later, where there's different levels of scaffolding in there. There it is. Okay, so let's crack on. So obviously you got those ideas. Keywords I see as well is really good. Let's keep moving. So what I'm going to first of all look at before I go on to the kind of bar models is a themed approach. So this is a little bit of a different definition or application of problem solving. Rather than a problem solving at the moment is like a kind of awkward exam question on a topic that you've learned, and different areas are coming into it. This is looking at it in a much more holistic way and saying, right, we've got this kind of problem, and we're going to use maths to solve one big problem. So what we did at my school at Gumley House was, some years ago, we taught the whole of Year 7 in themed projects. Now this is a big investment of time that we took writing them. The only one we actually, most of them were written in the house. The only one where we actually got some ideas off the net were the Maths Magic one, where we got quite a lot of ideas from Kangaroo Maths and adapted that. But the rest of them were kind of written by us in-house. Now what we did was we carouselled the students, and the teacher owned the project, so they taught that project with half the year group, set 1, set 2, set 3, set 4. So they both basically met most of Year 7 in Year 7, and the payoff there was when they picked up a class in Year 10, they knew most of the kids, so sometimes the behaviour issues were a bit less because you kind of developed that relationship and knew them when they were young. We were thinking of doing it as a mixed ability, but we kept it in sets so that we adapted the projects for all the different groups. Now, again, it would be a whole training session to look at those projects, but I have put them in the Google Drive. So in the Google Drive link folder, again, you might just want to jot it down on a pen and paper, but if you go into the Google Drive link at the end and then go into the folder problem solving, you'll see that it's, I think it's file 9 or 10. It's in the problem solving folder, and it's called Gumley House Projects, themed projects. They're for Year 7s, and they last round about half a term each. And there's a dedicated test for each of them. There's a scheme of work and hyperlinks, and everything's there. But they were really, really good. We stopped using them a few years ago when we went to a 2-year Key Stage 3 and a 3-year Key Stage 4. Then we stopped using them. But we used them for quite a number of years. But anyway, they're there. That's a slightly different approach. Something you might want to look at, something you might want to bring in at the end of term just by trying one of them. It's certainly something that if we keep going online teaching, it might be something that could be of interest to you. But they're there anyway, and you can just pinch bits from it. The other thing is the rock club that Syra presented at the beginning when she was doing her introduction and mentioned it. Now this is again using, this was done by a guy called Graham Smart, who's been doing some of those lessons twice a week for Pearson. There's a whole folder again in your Google Drive called Rock Club where there's all sorts of materials. And what it is using mathematics and areas of mathematics to design and devise a whole rock concert with, obviously, with at the moment there's a bit of a no-no with gatherings. But I'll give you a couple of examples from it. We're going to look at a video in a couple of minutes, or then when I give a prompt. But basically, you could do it as a separate class. You could get them all together when we can get them all together. You could break it up into separate little lessons. I used it once just took an idea because they had the different stage designs and had the lights. And the lights have a kind of footprint, I suppose, depending on the size of the bulb and the way it's focused, like the spotlight. And you have to put the lights around the stage. You have a certain number of lights. Where do you put them so that there's no part of the stage that's in darkness, so the act can stand anywhere and still be lit? But again, we don't want to just have too many lights because we've got a certain bill to pay electricity and hiring. So we need the minimum number of lights to actually light up every bit of stage. And that's problem solving in a practical context. So just to get an idea of how it works, and again, all the materials and videos, a bit like Boland maths. Anyone who's got experience of Boland maths, this would be something very similar along those lines. But anyway, if I get my host just to play the intro video, it's a couple of minutes. You might need to adjust your volumes. I'm not sure it could be louder than me or less loud. So I'll let the host play it now. It's a little intro video just to give you a flavour of it before we move on. So, thank you.
My name is Gina Coates. I'm a tour and production manager. It is my job to run large-scale concerts and festivals. I've worked with pretty much every band you've ever heard of, from little venues, from arenas like the O2 Arena in London to Wembley Stadium, and I run the festival. Rock Club aims to give you an insight into my world, and you'll be using maths and the skills that you will be learning anyway. Hopefully from this you'll see that maths is actually a really useful skill to have and very helpful in the real world.
The idea behind the suite of Rock Club resources was basically to put the pupil in the position of organising the big event. And the big event in this case is to be a concert. So what we had to do was we had to break the ideas down into small chunks that covered all the planning and the delivery of organising such a big event. And we did that in two different ways. We did it so that it could be delivered as separate sort of 1 hour lesson chunks, and also could be delivered as a one-day sort of full task sheet. So today what we're doing is, for instance, we're delivering it all in one day. The point is here is that problem solving is at the heart. The idea is they've got to organise this big event, and what skills do they need to use in order to organise this event. And this covers all the four corners, if you like, of the maths curriculum. So we've got the shape of space, we've got data handling, we've got algebra, we've got a lot of number work, and it's all done in a real modern context. It's linked to the real world, so we're talking about things that are really relevant to them, Twitter followers and things like that. It's done in a very relevant and engaging way. These resources are designed not only problem solving at the heart, but to try and get the pupils to see how they need to use different skills from within the maths curriculum to solve one larger, bigger type problem.
So there it is. You've got a flavour of that. So these two approaches that I've been talking about. Sorry, I think I muted there. Sorry. These two approaches that I've been talking about with the Rock Club, and here are links to other videos. But everything's in. It says 12 lessons there, but obviously you could do more or less lessons. They're all in the folder, in the Rock Club folder, in the Google Drive link for folder for problem solving. So there we are. Embedding problem solving. This is more kind of Monday afternoon lessons, more how you would do it on a day-to-day basis rather than the themed projects and the Rock Club, which invest a large chunk of time, an almost curriculum overhaul there, but there we are. This is what I saw when I visited the school. I believe it was in Liverpool. It was a very long time ago. And what the teacher did was the top bar that you see there, the recap was the last lesson, so that would have been a starter. The middle one, the grade 4, was what today's lesson is. And then the arrow is what's coming next, so the students had the kind of big picture. But what interested me, okay, we had a literacy word search there, if you like, countdown, and their little brain teaser. But numbers 1, 3, and 4, those 3 boxes there, obviously all the boxes interchanged, but it was always a literacy, there was always a brain teaser. But the 1, 3, and 4 could be any topic that was taught in the previous term. Depends how long it was, or the year before if it was September. So if you look at number 3, that wouldn't be a problem-solving question in your money at the moment if you were teaching it, because you're kind of fluent in those basics and in the different, different types of angles. You have alternate angles and corresponding angles, angles in the triangle, similar shapes. The thing is that if that question comes up 3 months later, then it does become problem solving, because they begin to forget the underpinning maths they should have learnt. And then it's keeping the old skills ticking over at the same time as covering new work. And this is what I liked about it. So anything could come up in those 3 boxes from quite a long time before, and it was just to keep things ticking over. And I think that's a really nice approach, something I took away with me on that particular visit. There's the answers to the anagrams if you're into those. This is an example of something I would do as a plenary at the end of teaching fractions, just to stick in a question like that at the end, which hasn't got any scaffolding. There's lots of different steps, and I was really surprised when I set this one, because it was a high ability class I threw this in, and what a lot of them did was they subtracted the 2 fractions to get the distance between C and B, and then they kind of halved it. But then they didn't answer the question. They thought that was the answer, and the actual question is how many miles is D west of A, and there's one additional addition to do, and a lot of them didn't do that, and so it was kind of encouraging them to make sure the number of marks, check their work, and answer the question. Look at the bottom line. A lot of them just jump in and just think, well, there's some missing gaps there. They're bright kids, and that's kind of what they did. So strange. Other useful resources and sources that I've found, which again, these are in that Google Drive. So I found some old functional skills questions. Linked pair pilot. I'm not sure if any of you know about the linked pair pilot or remember it. It was a double GCSE, like a double award, a bit like double English and double science. And there was going to be 2 papers at one stage. There was the applications exams, which are functional and got lots of problem solving questions. And then there was a second paper of methods, which is really AO1. And so I got some of those papers. There is in the Emporium a whole folder full of them. I only put a few in there because of the size of the Google Drive and the restrictions of the size. But in the linked pair pilot folder, so you go into GCSE and linked pair pilot, you will find a whole load of papers. There was about 100 centres that trialed it. Sorry, I heard some sound there. And they're very useful. Those application questions are quite, I'll show you one in a minute, they're quite demanding, they're quite tough. The other thing the linked pair pilot had was it had Venn diagrams and areas under graphs and gradient of a curve. So there was some new 9-to-1 topics in there. So again, you might use it for a source of some more examples. The Olympic papers, again, I've got an Olympic paper folder in the Google Drive where you can find those. I've put some of them in that problem-solving folder, but there's a full set there where we've got gold, silver, bronze versions of the exam papers. Again, I'll show you an example of that later on and how I used to use them. And finally, there's a topic tests folder where there's chapter tests, and often they will have problem-solving questions within those. So I've put those, if you look in the topic test folder, there's 2 sets of tests for each topic. They follow the order of the Pearson textbook, but again, I've got a glossary of what topic, whatever scheme of work you use. So this is an example of a workshop. So what we used to do was even in Key Stage 3, we used to have these workshops where for some of the lesson, we didn't teach the topic anymore. We taught our topic, we did some examples, we set our homework, and then we just handed out these sheets, and they could be anything, generic questions, just about kind of solving problems for the students. This is an example of a foundation one. And if you look at that gazetteer, I think they call it used to be in the AA book, showing my age many years ago, the distance between these places like London, Cardiff. A lot of students don't know how to use that little look-up grid for the distances, and so just by showing them and having an example, and these came up. These questions are from the linked pair pilot papers, and it's quite interesting actually. If you look at the fuel at 98.9 p a litre, a couple of 2 or 3 months ago, pre-lockdown, that would have been very cheap. In fact, it almost got to that price. I think it's crept up a bit at some of the supermarkets during this lockdown period because the demand for fuel went down. But anyway, there's a couple of examples. There's a couple more. Again, you can see the themes. This is from a functional skills paper and textbook. I got these ones from. Mixing the hair dye and different fractions and different proportions on the right. On the left, decorating a bedroom. So it's all good functional stuff. So the students, I think problem solving is better done much younger. That's why we started with those Year 7 projects, because they're used to thinking and talking and working collaboratively in that way, and it's much earlier on. But that's quite nice. Now this one is from the linked pair pilot applications papers. That's a nasty one. Maybe it could be one that you use the bar models for. But that's not an easy question. There's a lot of reading there. There's no scaffolding. That's a tough one. Try that with your class, and you'll find a lot of them will find that very difficult. And this one was done by Graham Smart. It's a little bit small on your screen, but this one's got 3 different job offers, and it's very open. Which job are you going to pick? And it's a clever one, this, because when I trialed it with a class, some of them used tables, drew little tables. Some of them tried graphs. It's quite open-ended. One job pays more at the beginning, but then the other one will kind of beat it if you stay longer as a kind of bonus. So it's quite an interesting one. Again, collaborative problem solving, and I think in a way this approach lends itself to remote learning quite well, and it's fed in by a lot of what you were saying when you did your comments. So for example, someone was asking where is the linked pair pilot. So the linked pair pilot is in the Emporium folder, so you have to go into the Maths Emporium, and it'll be part of it's an earlier form of the GCSE, a kind of trial of the GCSE. So you'll find it in the GCSE folder as linked pair pilot, just before the current GCSE. So it's in the GCSE cabinet, and there'll be a linked pair pilot one there. Now this is something I used to use in face-to-face lessons, but this could be done remote if you're doing a lesson using a platform where you can see your class. And you could say to them, well, here's a problem. You could give them this problem and say, right, you don't have to do it. Now, when I used to say that, the kids thought I had 2 heads. A maths teacher saying you don't have to do it. But what I'm saying is, don't jump in. No hands up, because often the bright kid will know how to do it and will just give the thinking for the others. I used to get them kind of discuss in their groups or pairs or tables and say, when you decide what the first step is, put your hands up and tell me. So then it was under my control who I was going to ask. And it would be something as simple as draw a diagram. Again, it's a bit cheesy. I used to say, if it's tricky, draw a picky. And that kind of gets them going. It doesn't have to be a diagram, but often it is. And then, right, now draw it. Don't carry on with the question. Just draw the diagram, and then we'll come back and look at it and assess it and think what the next step's going to be, and then we'll agree. And so by doing this kind of collaboratively working on it and putting their, deciding what the next step was and having a challenge, you're going to do that as your next step? Or how about that? You said you were going to do this. Which one do you think's better? They eventually start doing the question. Because what you're doing is you're putting the steps in, but we're doing it together rather than telling them. So this I used to find very useful. The Olympic papers, as I spoke about. Now, there's two ways you could use these. The first way is just if you've taught a topic, generating a plenary or a starter at the next lesson by choosing an appropriate question for the topic you've been teaching. There are now versions of most of the past exam papers done as gold, silver and bronze. So the gold is the question as it appeared. Now, if you're doing an exam, well, I've said the exam papers are. Now, obviously, at the moment, we haven't had the exams, but the mocks. So supposing the next time you do a mock, you choose a previous paper. That paper will have the gold, silver, bronze version in the Emporium cabinet, and I've collected them all together already in the Olympic paper folder. So you'll find June, I don't know, November papers are in there as gold, silver, bronze. It's only the AO3 question, so you won't find the gold, silver, bronze version of an AO1 question because there's only one way to answer it. It's just straightforward. But if it's something like this, where there's different, if this is a problem-solving question, what you'll find is you've got the gold is exactly the same as it appeared in the exam. So the silver, so if you've either taught this topic and you want to do a plenary there, I'm going to start you off on gold. Now again, starting them off on gold is high expectations. Some students will find that difficult. Certainly this was on both tiers and the success rate was extremely low at foundation level for this question. You can imagine why. So you could either, and this is how I used it when it was exams, I didn't start them all off on gold. I marked their exam, gave it back, let's do your corrections and do the rag sheet or whatever. And if you got your target grade or higher, I'm going to give you the gold version to do your corrections because really I want you to be value added. It's excellent. If you're one grade below your target grade, I'm going to give you the silver version, which has got some scaffolding put in to help you do your corrections. And if you were 2 or more grades below your target grade, I'm going to give you the bronze version, which has got a lot of scaffolding so you can do your corrections. However, in the real exam, it's going to appear like this. So you need to learn from those corrections. Now, that's when I was doing it as a correction of a mock. In other words, their correction, their support for their corrections. Because if I'd have just said correct the one you see in front of you as it appeared the gold, a lot of them aren't going to be able to do it if they couldn't do it in the exam. They might, but a lot of them will either copy a friend who got it right, or they'll end up doing it on the board, and copying isn't learning. So I want them to have a go and at least pick up some of those progress marks if a question was going to come up like that in the future. If you use the shadow papers, you could still use these because they're not based on the shadow papers because it's still essentially the same question, just with different numbers or different contexts, or a different shape in this case perhaps. If you were using this as a plenary and you taught that topic, I used to start them off on gold, but then I printed off silvers and bronzes and left them at the back of the room so that if they got stuck, they could get up and pick up the next colour to support them. So they're all doing the same question, but the level of support is different. So someone's just asked, there are gold, silver and bronze exam papers, not the paper as a whole, they're only the AO3 questions. So they're one single paper rather than paper 1, paper 2, paper 3, but it covers the AO3 questions within that series of exams. So you really either give them out when you've given them all 3 papers back, or you could keep giving them, could circle the ones that belong to paper 1. But so there's 2 ways you could use those gold, silver and bronze. But what it's doing is it's making a problem-solving question that's very demanding, more accessible to the students through something that's been done by Pearson. And I think that's really powerful. Now we're going to concentrate on the bar models, which is kind of the next 20 minutes or so. Okay, so there we are, just checking my... See this question here, okay? I want you to, in your chat window, write down what you think the misconceptions would be for your students trying that question. There we are. There we are. Here it is again. Sorry about that. Okay, so what would your students do if they tried that question? Yeah, it's all I see lots of 2 plus 5s. Okay, why would they do that? Answer that question. Why would they do that? Why would they do 385 divided by 7 or 105 divided by 7? Why would they do that? Habit, I like that. Not bother reading. Yeah, usually works. Yeah, and that's exactly what happened when I trialed that with my class. I said, write your answers. I used to often get them to try a question. I'd write the answers on the board and then give a prize like chocolates if they got it right. And most of them said 2 plus 5 is 7, 105 divided by 7. One of them said, that's silly, sir. She's silly. I don't call her silly. It's 385 divided by 7. And I thought, you're both silly, but I didn't say that. Because obviously it's an algorithm, and what they're doing is they're just going through, because that's what you always do. In terms of statistics, and I've got them in front of me here, when that was a live exam paper, because I have some statistics on that, at foundation tier, this is on both tiers, at foundation tier, 93% got 0 marks by doing exactly 2 plus 5 is 7, and if you don't start it right, you've had it. And at higher tier, 54% got 0 marks, and they're going to do A-level. And 31% got full marks at at higher tier. At foundation tier, it was about less than 1%, I think, got full marks on that. And we can see why. Okay, so this is one at higher tier, which I think, now, when I trialed this with higher tier, some of the bright students going for an 8 or a 9 could do it, and they didn't need bar models. But still, quite a significant number of the class weren't sure how to approach it. They really weren't sure what to do. So we'll return back to those questions a little bit later when I've done some kind of presenting on bar models. Again, there's a whole folder in that Google Drive in the problem solving folder called bar models, and you've got some extensive PowerPoints just on bar model questions. I'm taking some of those slides now, but you've got a lot more detail there. So when are bar models used? They can be used for percentage questions, fractions, ratio, and even simultaneous equations. They're a bit limited with simultaneous equations because with minuses they're much more difficult to do. But you'll see a simultaneous equation one, which I used as an alternative for my top set. But really, I preferred them to use algebraic techniques, as a lot of them were going to go on to do A-level. But it's there as just an alternative. The question is, when you have the bar models and you have the bars, how many boxes do we split it up into? So this is, again, I'm kind of doing it as a teaching thing. And I say, well, you need to look at the question. If it's a fraction question, the clue is in the denominator. So if it's out of 8, probably you need 8 boxes. If it's a percentage question, because of 100% and we work in 10%, you probably need, I remember asking that and someone said 100 boxes. I said, well, I don't think we've got quite enough time to draw 100 boxes. We'll go for 10. So when it's ratios, it all depends really on what the ratios are. So do we need 7 boxes for that previous one? Maybe not. So this is kind of, there we are, 10%. You just saw 1/10 there. Okay. So this one is the standard one where they would do 2 plus 3 is 5. Not like the previous one that we saw because they didn't read it. But I think if we look at it from a pictorial point of view, and in my previous session, for some reason I left them upstairs because I put them away. I had some Cuisenaire rods. I don't want to leave the thing and come back, but I used to use, I've got some Cuisenaire rods, which you can get an app on your phone for them, and so I'll just squared paper. I think some, or multi-link cubes. I know they make guns first or towers, but I think by having those multi-link cubes, or something they can play with, the kinesthetic learners can find it a lot better. I see some nice suggestions coming up on the chat window for different resources for bar models, which is really good. But this one here, the key to it is that £20 goes across all 5 boxes because both of the girls are sharing the money. And so 1, 2, 3, you've got 5 boxes belonging to £20 is shared among 5 boxes, so it's 20 divided by 5. And again, the weak students, I used to make them write the £4 underneath each box, and then you can just work it out. But that's why you divide by 5, because the money's being shared by effectively 5 boxes. Now, this one here, you imagine giving that to your foundation class. Again, very quickly in the chat window, what would they do when they saw this question? What would their hunch be? What would their calculation be without using bar. Leave the question. Panic, I see. Yeah. A lot of what you're writing down is exactly what happened when I tried it with my class. A lot of them looked at the 1650, looked at the half, and thought, I better half 1650. Let's do something in desperation. And this always reminds me of when I was training to be a teacher at St Mary's College in Strawberry Hill. The guy running the course was Hungarian, and he came in one day and he started speaking Hungarian, and he started doing the seminar in Hungarian. Now, the interesting thing is, and then he put a question up, and it was in Hungarian. So can you imagine if this question was in Hungarian, where the only thing you could really read, unless you're a Hungarian national, of course, is the 40%, the 1650, and the half, maybe the word Sophie. In a sense, that's what it's like for students who either have not got these skills, English second language, I suppose, but if they don't read the question, you might as well write it in a foreign language, and all they'll do, and he said to us, try the question, and we said, we can't do it because it's all in Hungarian. He said, well, have a go. And we just took the two numbers and added them and had a punt. And he said, there you go, you got it right. You can understand it. And I said, well, no, we were just lucky. And that's the point of this, really. It's the language, isn't it, that's the barrier. So let's have a look at this in a bar model way. So I'm going to go through it in quite detail, and then I'll give you one to try. Okay, so have a pen and paper handy. Not this one, a kind of similar one. And then there's a worksheet with lots of these in the bar model folder in the Google Drive. So, first of all, we draw a box, and it's a percentage, there's a half. So how many boxes do we need to do? Well, it's a percentage question, so we'll go for 10. The necklace, you can just see the necklace there, is 40% of the money. Now, this is the key sentence. Half the remainder is earrings. Now, when I trialed this with a class, one or two of them put the earrings over 5 boxes because they said half of the thing is earrings, not half the remainder. So can you see the misconception there? So it's half the remainder. So that's there, 3 out of the 6 remaining ones. And then she is left with 1650. Now, if you see that, I think the student gets a process mark because they've understood the question. When I did this seminar, this session last time, yes, someone said about underlining the key words. Yeah, when I did this session last time, 1 or 2 delegates asked, "Would you get marks for doing a bar model in an exam?" And the answer is yes. Although we don't really see bar models on mark schemes, I think they may come in future. But again, Graham might be in a better position to answer that than me. But there we are. So there it is. So the person gets a process mark. I think if they get to that stage, they can almost finish it because then it's going to be, there's 3 boxes being the 1650. Do you remember last time the 20 went across all 5? Now the 1650 only belongs to 3 boxes. So it's 1650 divided by 3. Often on the mark scheme it will say things like 550 seen. Well, there I have seen it as another mark. And then again 550, 550, 550 is 10 lots of 550. And so her birthday money is £55. And that's a nice way of doing quite a demanding question. And again, the success rate of that would have been pretty low if it was in a live paper. So I'm going to give you a minute or 2 just to try this one with a pen and paper. So have a go at this one. Give you a minute just to draw it down. I'll just wait for a sec. And when you've got the answer, if you just pop it into the window. Remember, we're looking at the number of people who went to the pantomime all together. Some of you are quick. There we are. What you probably found that there was, I think, 3 boxes with the women. And so that's 45 divided by 3, so it's 15, and 15 times 10 is 150. So can you see how it's become quite a nice question if you've got that approach and you're using it to model it? And I think the weaker students can at least get some marks. And I think if you go so far and you get a nice diagram, you're going to almost be able to finish it. That's something you might want to try if you haven't tried that before. The next one, and this is getting more towards our problem we saw at the beginning, the one with a really low success rate, with the 2 + 5 is 7. If it's a more than, again, they need to be taught these things. You can't just learn it themselves. If you see more than or less than in a question, now I used to show the more than advert. There are other insurance companies around, but I used to show it to them as a kind of little taster, just as something to trigger in their mind, something they could hold on to. If you see more than or less than, then it's no good drawing the bars above each other, because one is comparing two different bars. So have a look, something like this. Now, there's obviously 25 more girls than boys, but you can see the 25 more protrudes, the sticking out bit, the extra bit. Or you could say there's 25 less boys than girls, rather than the 25 more girls than boys. And then it's very easy, 25 plus 125, 150. Now that's the clue. So I said to them, and the key words, when you see more than or less than, you have to draw the bars like that. You can't draw them in a line. It's not going to be easy. Now, this one here came up in a sample assessment material, so it's never been on a live exam. The key sentence here is the second sentence. Emily got £80 more than Liam. Now, I used to say to the class, okay, I used to point at a student, say, or two students, say, I'm going to give you £80 more than you. Okay, how much are you going to get? Say, I don't know, depends how much that one gets. I said, exactly. Doesn't mean you're going to get £80 unless they got 0. So at the moment you can't tell how much any individual person has got, but you know one has got £80 more than the other. Why are you doing it? Oh, you quick you lot. Alright? So if you try and draw them in a line, you're not going to get anywhere. And this is the people who are writing these 48s. You can see there that Liam and Emily, the bars are above each other, and that extra bit is the £80, and then it's £16, 80 divided by 5, and then each bar is 16, each box is 16, and then it's 16 times 3, which is your 48. So again, quite a tricky question has become quite accessible there. Okay, I'm just conscious of time, so I'm returning to this one. I'm not going to do it. You probably need a calculator, so don't bother doing it, because I'm going to move on. But that question there, now we can clearly see that you need to draw the Kim and Molly bars above each other, where Kim's bar is longer than Molly's and is 105 more, and then you could do it that way, 2 and 5. So the 3, it's really 105 divided by 3, not 7. So there we are. There's a decimal percentage, but you got it right, whoever answered it. This one here, can you see the hint? The thing is, this is Mr. Smith. So Mr. Smith overspent his budget by 2 1/4. So the budget is the 1. So they've got where the budget for 1 is. Then I'll use my pointer actually on this one. So what you've got is this is the 1 here. This is the 2, because obviously we got the 2 1/4 here. So there's 1, 2 1/4. And what that means is these have to be split into 4. And here, right? Because it's quarters. The denominator kind of does it, as we said at the beginning. And so we got 4, 8, we got 9 of them. And so his budget is then 405 divided by 9 to get 1 of them, and then times it by 4. If you were going to do the Mrs. Smith, because Mrs. Smith spent by 1 3/5, these ones, or the 1, would be broken up into fifths, okay, because of the fact it's in fifths. So that, again, is an example where bar models can be used to do a fraction question. How I used this with my top set was I expect them to do it using fractions. However, if anyone was struggling, they would come to, I had this tuition table I used to set up. They would come to my tuition center at the back, and I would work with a group of them, showing them the bar model way of doing it as a tool for if they couldn't do the fractions. Whereas I expected a lot of them to not use it because I knew they were going to go on to do A level, and I didn't want them to rely too much on it to do this question and do the kind of more standard way. But there it is. So this is the worksheet. And you can see, this is some of them, obviously up from number 5, and you can see there number 5 was the one you did, wasn't it, on the pantomime, and Number 9 was the one I showed with the, and in fact, it's quite a topical one, number 10, with the flu being passed. They obviously must socially distance, but they're not, and it's being passed around. That's actually quite, those two challenge questions are quite hard, actually, if you want to try them with a class. They're quite tough. So it's a bit like the Mrs. Smith and Mr. Smith's Christmas money one, number 10. But that worksheet will be provided for you for an instant link with this PowerPoint at the end of the course, but it's also in the Google Drive, remember, problem solving folder, and it's in the bar models folder within that subfolder. Now, simultaneous equations. So again, I'm looking at the clock, so we haven't got that much time. If I was doing a full one-day, course, I'd get you to try this using algebra. What I urge you to do is try this using algebra at the end of the course, because what you'll find is the algebra will link directly to the bar model. Now you can see we've left Europe. It's in dollars. Yeah, someone was saying about White Rose website is good for those types of questions. Yeah. Building up that one. So here we are, Anne and Beth. Now, tell you what the misconception is with this when I trialed this. A lot of the students think the bars have to be equal size, or each box, not the bars, but the boxes within the bars have to be equal size, because that happened in all the other questions. I mean, that's how we worked out the money, the 3 16s earlier for the money, for Sarah, I think it was. But if you look here, that's why I've used the 2 different colours. So Anne is blue, and Cindy and Beth are pink, but I've used pink for Beth and Cindy because there's a relationship between Beth and Cindy, that one pink bar, the Cindy one, the bottom one, is 3 times the length of the other one. Now, again, that's the question. I wouldn't give a process mark for that yet, because I'm not convinced they understand the question. However, they understand the question. I'd give them a mark for that, because you can see that one is 3 times the length of the other, and what we found is that the 2 additionals are 74, which means, that's right, some of you have worked it through and got the answer. There's your 37. So if you were doing this algebraically, you'd see some subtraction of the equations, and you'd see a 37 appear, and you'd see a 74 appear, and then you make a substitution at the end, and there's your 20. So it's actually quite a nice way of doing simultaneous equations. I think the disadvantage is, I have actually, someone did ask me to have a look, and I did have a good look, and I couldn't find anything. It's very hard to do, maybe some really old SMP stuff from years ago might have it, with more balances doing it as a tool. It's quite hard doing bar models for simultaneous equations where one of the equations has got a negative in it. I think that's going to be much harder. You'd have like gaps and things and dotted bits. But for pluses, it's brilliant. Okay. This is a worksheet which I used to use for my very first lesson when I was doing this topic with higher tier students, because they're higher tier, and I wanted them to see how these equations could model a question. I actually only marked, $20, not £20. I only marked A, the missing equations, and 8, the missing sentence, because anyone can match them by just looking at numbers. Remember the Hungarian lesson? So someone could look at the first one, and it says 20, the sum of 20 and the difference of 8, the one that's linked, and then C, they just link the 20 and the 8. They don't need to know anything. But they have to be able to write a pair of equations for the missing one, so they need to do all the matching first, and then the missing equation, they need to write a problem. And that's the only 2 that I mark, because that shows the learning. For foundation, I used this as my last lesson when they'd got fluency in the topic. It would have been too much to give foundation kids that from the word go, because they really wouldn't have known what the hell was going on. So I gave that as a foundation plenary, but as a starter for higher. Show that questions. I'm briefly going to do this, but again, I think the gold, silver, and bronze versions of the papers will help with this. But here's a couple of strategies. So here's a question where they've got these 2 similar shapes. Now, what I used to do if students struggled with this, I say, look, get a pencil and make the 15 into an easy number. Or you could make the 10 into an easy number, but the 15's easier. So what easy number shall we put in for the 15? And they say 20. then it's twice as big. I said, okay, now do it. And well, if the perimeter of the small is 46 and it's twice as big, 46 times 2. I said, obviously not going to make 69 because it's not the same question. Okay, but how did you get that 2? Because it's double the size. What did you do to the 20 and the 10 to make the 2? 20 divided by 10. And that gives you the 2. So now rub out the 20 and now do it again. And they could do it. So that's a strategy. So this is the kind of standard. That's that times 1.5. That's the bit they'll find hard. And that's why by doing it with the 20, by timesing by 2, they might have a chance of realizing you're timesing by 1.5. You could even say they're the same size, 10 and 10, you times by 1. If it's twice the size, you times by 2. It's kind of 1.5 times bigger. There's a number of ways into it. But I used to make them put a nice number in and then do it with a horrible number afterwards. And they do the same thing. Yeah, someone said a lot of these questions end up with 1.5. Yeah, not all. But there we are. And there's your answer. And what's nice is they can check it. I said, look, it's really good the fact you've got the 69 there. Never work backwards from it. That's what some of them will do. And then they get into trouble and they don't get full marks. Or any marks in some cases. Depends on the mark scheme. But it's nice to have the 69 because you know you've got it right. So that's a positive. Here's another one. Now, again, this one is one of the ones where you could say you don't have to do it, but tell me what the first step would be. And again, I'm going to use the arrow here. That's the easy bit here, right? 75 angles on a straight line, right? Then it's kind of, well, okay, if you've done that, which triangle's got more numbers in it now? This has got out this one here, and we've got the 38. We know the angles in a triangle. And make them cover this triangle. Cover it up with your hand or a bit of paper. And then just work on that triangle. And it's just a question, and I wonder how many students will do this at each stage. They lose marks if they don't do that. And they're quite fussy about the reasons these days. Remember the underlined ones that have to be there as a minimum requirement. So they're kind of not accepting things like, if you think of that first step, the 75 from 180 as 105, they might say that a straight line is 180. Rather than the angles on a straight line add up to 180. They're not as specific and they will lose marks. It's harsh because you know they understand it, but they're not being precise. So it's one of those things. So that's a good question where you would have, you could do it. There probably is a gold, silver, bronze version of that in the sample assessment material because not just live papers are in that Olympic paper folder, but there's also versions of the sample assessment and specimen papers in there, and probably there's a gold, that's the gold you're looking at, but the silver and bronze would have the different steps that the students have to do themselves. One thing they shouldn't do, though, is you see the answer is 31, is to feed the 31 in and work backwards. Then they're really skating on thin ice. Not a good idea. But a lot of them will do that in desperation. There's the kind of mark scheme, and there's your process marks, your P marks. They're a bit loose, some of those P marks. For a P1, for a correct start to a chain of reasoning. Well, what's that mean? I think the top bit, where I actually work out that 105 angles on a straight line add up to 180, it's all there. So sometimes the process marks are a bit loose because there's more than one process, but it's nice to have something solid to work towards, as you see at the top there. So sometimes the mark schemes aren't particularly useful. Certainly the student-friendly ones are really good that have been produced. Student-friendly mark schemes are worth looking at if you don't know about those. I've collected most of those together in the Google Drive in the GCSE 9-1 paper folder. Much easier for students to check. Now this one here comes through an international GCSE from January, quite a recent one. What I'd like you to do for this one, again, my host is going to put a chat window up on this one. I'm going to ask you to look at it and say, you know, what was demanding about it? Why is that question hard? Yes, I can see a few people thinking of the, if it's tricky, draw a picky. And also there's surds in there, can you see? The root 80, so that's that fluency for different parts of the curriculum. They've got to be on it. There's a lot of mathematics there. I mean, you would argue that this could almost be an AS level question. You know, what grade would it be? 8, 9? It's got to be right up there, isn't it? That's a very, very difficult question. And I haven't got the statistics, but the success rate, I think, was extremely low for that one. The examiner's report came out fairly recently for that one. It's a good question as a plenary, though, or a class discussion. Hard. Let's have a look then. Thanks for your suggestions. So this is why it was demanding. As I say, there was no diagram was given, you can see there. And it became algebra. And if you look at the bottom, do you remember that familiarity we spoke about at the beginning? No problem had been set by Excel before. Again, if it comes up next year, or something like it, probably they'll be better at it because they've had a go at it. It's not as unfamiliar. So that's why it's so often worth looking at the international GCSE papers, because they've had a lot of the reforms we've had. Certainly for A-level, it's worth looking, if you're an A-level teacher, at the international A-level papers in that folder in the Emporium. But I have got an international GCSE folder in that Google Drive link that I'm sharing with you. I haven't put all the papers in there, obviously, because of the size, but I put some of the sample papers and some of the materials to support some of the international schools, or some of the schools who are doing IGCSE or international GCSE, I should call it. So it's worth looking, but that was a good question. And this one here, it's not Hannah's Sweets, it's Boris's Sweets. I wonder where they got the name Boris from. But this one here, again, that came from June 2019 2H. Again, I think this is hard because can you see those three bullet points there? That's really the knowledge they need to even attempt this question. Perhaps this question will be better answered now as it has become more of a Hannah's Sweets type thing. There we are. In the practice papers folder in the Google Drive, there's a folder called practice papers. There's a subfolder called themed, Edexcel themed practice papers. There's a whole load of Hannah's Sweets questions as a little exam paper in there, if you're interested. Let's have a quick look at the solution for this one. Oops. Oh, that's weird. That slide's gone. There was meant to be pre-course. There was some missing font because when they copied it across to their version of PowerPoint, I used Equator, an equation maker, to do the answers. Sorry about that. It will be on the version that's in the Google Drive for sure. Okay. Sorry, it should have actually shown how it worked out, and it actually became algebraic fractions to solve the thing, like g+2 over whatever. It was quite hard. But there we are. Sorry, that's a missing slide there. Oops. I'm going to finish off for the last few slides looking at some generic teaching and learning, but in a sense it fosters the ability for your students to be better at problem solving. So these are the things, it's obvious stuff really, to encourage them and develop that kind of culture of not being frightened to have a go. That's really the heart of these bullet points here. Oh, there it is. It's just swapped order. There it is. So this is the solution to the Boris question. I knew it was somewhere, but can you see? Look at that. Algebraic fractions, and suddenly it becomes a quadratic. Now, can you see the g is minus, the g is 0.5? That has to be rejected. I think on that, the mark scheme for the international GCSE version, that question, I think if they didn't reject the 0.5, they lost a mark because of modelling and solving the problem and saying you can't have 0.5 sweets. And so the 12 was the answer. So there it is. It's just the order changed a bit there. Back to those generic. This is some research that I looked up on metacognitive learning. So you've got cognitive learning and metacognitive learning. Metacognitive learning is a higher order of thinking. And these are the things that you'd see if you read up anything about metacognitive. I've just summarized them there. But they are really the same skills that students need to be able to answer those problem-solving questions. Think of that Boris question we just looked at and the previous one with the coordinate geometry. They need to do those skills and reflect on the task. Sometimes suggested improvements can be in there as well as an assessment objective. To be critical and evaluate it and make suggestions and change things. So I think, in a sense, we're talking about quite a high order of learning, and it's something the students need to, it's not going to come automatically for them. But at the heart of it, the fluency has to be there. I can't emphasize that enough. So that's the link to the Google Drive. You will get it formally, so you don't need to get your pens and roughly copy it in. But these are the three main folders for the materials I've spoken about today. The Olympic papers folder, the practice papers, and the problem-solving folder. This is the problem-solving folder. And what I'm going to do now is I'm going to ask my host to screen share, where I'm now going to show you that folder in a little bit more detail for about 5 minutes, 6 minutes, and then we'll round off. The Google Drive will be put back up at the end of the conclusion of this meeting. I can't see any of the questions now at all, because obviously, so when you go into the folder, so when you go into the Google Drive, hopefully you can all see my screen now. I can't see any questions. So the Google Drive will look like this when you open it. Any new resources go in there for a month or two. So you see that new resources folder. So once you've done a download of the material in there, the new resources, anything new will go in there for a little while, because you're not going to have time to start searching for all the different folders, and then they are in their proper home. But the problem-solving folder is hidden by my box. I'm going to move it up. Here it is, problem-solving. And then we've got the bar models. So what we've got there is quite a much more detailed worksheet for bar models, a couple of worksheets for bar models, and these are from the textbook, actually, for foundation and higher bar models. That's where that Mrs. Smith question came from for the Christmas presents. So they're just a few worksheets of bar models. Problem-solving papers. So these are gold, silver, bronze, and just problem-solving questions. Just a paper full of problem-solving questions. So they're there, kind of random topics. Link pair pilot, there we are. I did put some in there. So there's some link pair pilot papers. I've only put a selection in, but there's a lot more than that. So you might want to have a look at remember it's the applications papers. So put some there. There's Rock Club. So there's the Rock Club. There's all the videos. This is there's resources. You've got links as well, actually, that take you to things. But if you go, I think, into www, I think you've actually got all the resources in there somewhere. Not www. It's a bit awkward on this, Rock Club. It's a bit like Boland Maths. You have to dig a bit, but there we are, Rock Club resources. They're all there. There they are. So you've got one complete set of teachers' notes, all the PDFs of all the handouts to make the thing run, and lesson plans. Rather like Boland. There they are. All right. So that's Rock Club. Whoops, I went too far back there. Yes, Rock Club. GCSE problem-solving papers. So here's a few more problem-solving papers. Okay. Olympic themed. Here, this folder contains all the themed and topic papers. So that is a zipped one because it's big, but that's where you find the Hannah Sweets. And there's ones like meter readings, electricity bills. So it's just a whole exam paper, DIY, full of problem-solving questions on a certain theme. Recipes, right? That's in there. Shared resources. These are ones that I've picked up from other schools. All right. So I picked these up from other schools I visited, like Jamie Oliver's cookbook, set of problem-solvings. Plickers, cards, I think all Plickers, which is a bit like Kahoot. And this circle theorems is a fantastic lesson where they show the circle theorems, they go through each one, they bring up a question, but then they show the examiner's report and the misconceptions, and then the students have some to try. That's a really nice set of lessons, or a series of lessons. You could run it for probably 2 lessons on that, on circle theorems. Very, very nice. I picked that up when I was visiting a school. Problem-solving techniques, that's where the bar models, it's zipped up, but that's where the lion's share of the bar model stuff is in there, okay? So it's all in there, the bar model stuff. And then themed projects, Gumley House. There's those projects. So there's the statistics one, Investigate the World, Maths Magic, We used to use the Level Up books for homework, this was quite a while ago, and there's some examples of pupils' work there, actually some nice shots. They've given permission, or they gave permission. They're probably, most of them are in the upper school now, but there they are. And then there's some topic sheets for each project. I think there's also a kind of letter here. There's a letter here which we sent to parents saying what the projects were and which part of the curriculum each project was designed to cover and target. All right. I'm going to go it live now into my own drive here just to open up one of those two that was zipped up for you. So if I go into the shared resources, I just want to show you one or two of the things in there. So if I show you that circle theorems, then I'll stop because I'm conscious of the time. So this is the one I spoke about that I think is excellent. So what it does is it starts with the examiner's report. So it says, you know, what the examiner said was not so good. And then write down all the facts you know from these diagrams. So it's a summary of it. Obviously, you have to have it taught. Revision. Quite good for year 11s, I'd imagine. There they are, just the answers. And then 3 different students. And you know, some of the GCSE questions are like that now, where you've got different students and who got it right, who got the most marks, because they've all kind of got it right, but who's given the best solution with all the reasons and things. And then there it is. And then write down what should be included in the perfect solution. There we are. And then here's one for them to try. Keywords. Answers to that one. And then some exercises. It's a lovely, lovely sheet, set of slides, which summarizes the whole thing, but really gets them thinking. So there it is. So I'm just going to minimize that and stop screen sharing. Just to give you a quick flavor of what's in the drive. There we are, so my host can come back. So that's 5:15, so I think I've more or less reached the end of, we obviously got Mark as well and any mopped up questions. Oh, it's gone. Wait. I think it probably is as good a stage as any to, while I'm flicking through the slides and giving her a bad headache, to hand back to Syra just to mop things up. There's the, there we've gone back. So there we are, and now we're into the Q&A session. So Syra.
Thank you, Pietro. So we've got a question. Someone's asking, what advice can you give to a new maths teacher? Pietro, you're on mute, I think.
Sorry about that. I don't want to have double voice. That's a good question. In the old days, it would have been observe a colleague, but you can't really do that at the moment, so it's very hard. I think the thing is, start small and make sure that when you select your questions, don't jump in with too hard a question at the beginning. Try somehow to scaffold it and give them some scaffolding rather than just throw them in with a really hard question. Look at the resources that I've given you, maybe those gold, silver and bronze, and have something where you've got scaffolded support versions, i.e. the silvers and bronzes, available so that you just give the students that confidence. It's really differentiation, isn't it? But it is difficult. It is difficult. Also, look at lots of exam papers and see the types of questions that were defined as problem-solving questions. But just, it's really practice. The textbooks as well will give you an idea, because a lot of most, again, we'll talk about the Pearson ones, but most textbooks will have problem-solving highlighted or signposted, or there'll be some examples which are problem-solving, and so they're the ones that you will need careful consideration whilst you're doing your teaching. The 2 pods have appeared down the bottom there. So the bar model worksheet with answers is the one with the, I showed you a screenshot of, with the hard ones with the flu, and the one that you did for the pantomime. And then the network support slides are there. They're the ones that were you could look through at the beginning of future networks. You might have joined late. And then there's the actual problem-solving PowerPoint, the one I've been presenting from, with the slide notes, hopefully in the right order. But there we are. And then the Google Drive link is there as well. If you just click on the actual where it says Google Drive link, you can then browse and put it onto your bookmark. So hopefully I answered that question. This is really practice, but when you get back to school, if you're a new teacher, you need to maybe observe other colleagues doing that. But don't jump in and make a whole lesson problem solving. It's often nicely done as a plenary when they've got that fluency. You've got to get them to get that fluency first. Otherwise, they won't be able to answer the problem.
Thanks, Pietro.
Anything else?
I can't see any other questions. There's lots of questions around how to access the Google Drive link. If you look on your screen, there's this box that says web links. That says Google Drive link, so please click on there. That's where you can access all the resources that Pietro spoke about today, and also Pietro's presentation, and also the GCSE support that we have in place. If you wish to browse them, they were shown right at the beginning. You can download them. There should be a box that says delegate download.
Oh yes, something I just wanted to say about the Google Drive link. It's a tiny URL just to save because it's a really long email address for the long web address for the actual Google Drive. If you have a Google Drive, then that's fine. If you don't have a Google Drive, you can still download by right-clicking on the file, and then on the drop-down box there'll be a download option, and it will often zip it up if it's big by default, but then you can extract all. Don't try to it'll only be read-only when it migrates with your Google Drive. Some delegates have asked for permissions to edit it and share it. I can't give those permissions because with the best will in the world, someone might delete something by mistake, and we need to know as Pearson what's in there. There's only a couple of people who can actually access it, because obviously some of the stuff we have to clear with copyright, and we need to know what's there. So I do get some, not too many now, since I've been saying this, but at the beginning I got quite a few people trying to allow me to give permissions, which I'm not going to give. I hope you can understand why. Just about the Google Drive. And the link will carry on. It'll keep. It's not like just for this. It'll be going as long as I'm able to do it.
Pietro, there's another question. How do you get high attaining students to show they're working and not just give an answer?
Well, that's a good question. I mean, show them the mark scheme from an exam paper. Let them do it, mark it, now if it's a formative assessment or a test or a key piece of work or homework, and just give them less marks and say, well, that could cost you a grade 8 or a 9, and that's a really silly way of losing that grade because I know you know it, but the examiner doesn't. And so I think that's probably the way to do it, is to let them learn the hard way, not the hard way in the exam, but if they're going to be stubborn about it. And you're right, the brightest students don't show the working, but you need to say the examiner needs to know that you know, and there are certain hoops we need to jump through to get the method marks, and it says you must show your working, you've got to show it. And if you cut corners, you're going to lose marks, and that might cost you the grade. Not because you don't know the question, because you can't be bothered to write the working. So you have to sometimes be a bit blunt about it, but I think that's probably the best thing. Someone's put, can you put the link back on the screen? The link is at the bottom. Hopefully everyone can see it. Someone's just put that. And if you just click where it says web links, when it says Google Drive link, if you actually click on that kind of blue thing, blue turns blue when you on mine when you touch it. If you just tap it, it will then appear right down the bottom next to the box called Browse To, and then if you click on the Browse To, it will kind of open. Someone's put it in the chat window, but there's so many of you, it keeps scrolling up, but it's at the bottom of your screen. I think someone's moving the arrow showing it. Who's sharing the screen? Can you see it down the bottom there? That's not me moving the arrow, it's quite scary, that. Anything else, Ira? And then, because I think Mark has got to say his bit to finish this.
We have another question. Someone says, how do you get the students who sit there and let others do the work for them get involved?
Yeah, I mean, this is tricky. There's a number of methods I've used. Obviously, that one about you don't have to, there will be passive students, there always will be. But if you can get them into groups of 4, now again, with this distance learning, that's going to be tricky. So I'm assuming now we're talking classroom. No hands up so that the bright ones don't dominate, and kind of ask them. You could support some of them separately, but in a whole class thing, when we're doing a question and you don't want them to be passive, I used to get them to groups of 4, 1 bright, 1 weak, and 2 average ability. So I didn't have a bright table and a weak table, and try and make them work collaboratively that way. It's tricky, but I think it's just giving them that encouragement and stopping the bright ones dominating. But also, if they can't do it, then having the silver and bronze and saying, now do it using the silver and bronze, I want to see you try it, because the scaffolding has been put in for you. Because if it's just an open book, an open question without any scaffolding, a lot of them will give up. And look at the exam stats for some of those questions. They won't do it because they haven't got that, they haven't developed that metacognitive learning, as so to speak. So it's doing that. It's really using the resources and the scaffolding, but stopping the bright ones dominate, which is again a challenge. Anything
Thanks,
else?
Pietro. I'm not seeing any more questions.
Right, that's good. So Mark is going to say his bit. We've got about 7 minutes to go before the schedule closes.
Unfortunately not, Pietro. Mark's not around.
So you can take over now.
There's a few people who are saying that once they've downloaded the link to the Google Drive, they've downloaded it, but then they can't find it. Is there anything you can do around this, Pietro? So they've downloaded the Google Drive, but then they
downloaded the link to the Google.
They've downloaded the drive, but then they can't access it.
Should be able to work. I mean, I'm just going to check on my own. I mean, when I was showing it to you, you know, when I did the screen sharing and I showed it to you, that was live on the Google Drive. It was open.
Some people said they need to be signed in.
Maybe have another.
Someone just said they need to be signed into Google to be able to then find their download. I think that might help with that person who's answered that question.
Oh, right. Right, that normally you don't have to have a Google Drive at all or a Google account for that link to work. It should just come up on your, even on an iPhone, it could come up on anything. I mean, again, I'm just checking the address is correct. It's definitely the correct address. A56MPE. If delegates have tried to just open it, if you could just put in the chat, in the group chat, yes, it opened, just to double check that we have given you the right address. Yes, you do. Okay, it's just maybe somebody. Yeah, that's fine. That's fine. But sometimes there's the odd person, not odd and odd, but there's the occasional person who you know, might have their Google Drive open. It's trying to migrate and whatever. But there we are. Thanks for that, delegates. It works well. Yeah. So is there any way, Syra, you can do what Mark was going to do? We haven't got the notes, and we could send it another way. But there is a little feedback form we'd like you to fill in there. I don't know if you want to say anything to that, Syra.
There isn't much more of an update from the last session that we ran, Pietro, around any off-court updates. There is a slide that I popped into the network slides around the latest off-court update if you wish to have a look at that, so please do. But as far as the off-court been quite quiet, we haven't heard anything since.
Okay. The other thing is that the next session I'm going to be doing is in 2 weeks' time, and it's a repeat of one I did earlier, which is looking at resources. But there's one next week which is being done by Just Maths, by Chris and Mel of Just Maths. Is that right, Sarah? You just want to tell people? It's probably on your slides, just so they know what's coming up next.
Brilliant, thanks, Pietro. Yes, so Chris and Mel, the Just Maths pair, are doing a network on Year 10s being Year 11 ready, just particularly those foundation and higher borderline students. Next week's session is fully booked, but we do have a repeat session on the 2nd of July, which we do have, you know, just under 50 spaces left. So if you do want to register, please do. It's the link is in the network slide that I have put. So the download, it says network support. So if you want to click on that and look at the networks, and register for the 2nd of July, please do. We have got limited space there still, so that's looking to get full very soon. If you do want to attend, please book as soon as possible. I also want to just mention that we are running online live lessons around problem solving aimed at all GCSE level students. In case you haven't heard, they're on YouTube every Tuesday and Thursday. All information can be found again in those network support slides, so please do have a look and read, and if you wish to direct your students to them, that would be fantastic. I think that's all from me, and I don't think we have any more questions. So I'm going to say thank you all for attending today's session. We hope you found it useful, and I'd like to extend a massive thank you, as always, to Pietro for your support. Just a quick reminder that the link to the Google Drive is on your screen, as is the presentation. It's available to download, so please do get those. Also, please do take 2 minutes to complete the evaluation online form that will pop up on your screen as soon as the event has been concluded. And thank you once again, and I hope you have a lovely evening.
And thanks very much, everybody. Thanks for being your kind words through the chat window. I hope to hear or see you soon, maybe. And thanks a lot, and hopefully you found that useful.